So for a question like this, you're being asked to find the initial value and the rate of change. Now, in a table of values that gave you nice numbers, and maybe you're lucky enough that yours did. Some of them do, some of them don't for this question. But if we had 0 and 3, 2 and 7, 4 and 11, and 6 and 15. There we go. We could at least get the initial value easily, because remember the initial value is y when x is equal to 0. So here, that's really easy, because when x is equal to 0, y is equal to 3. So the initial value here would just be 3. Very easy number to find, which is nice. Over here, it's not that easy. It's not that easy at all, in fact. So we're going to have to start with the rate of change. And remember, that's always the change in y divided by the change in x. In other words, as x is changing, how much is y changing? What's the ratio there? And the way we do that over here is we would just say, okay, well, what's happening here? 3 to 7, that's going up by 4. 7 to 11, that's going up by 4. 11 to 15, that's going up by 4. So the change in y, in this case, is 4. And over here, the change in x, well, this one goes up by 2. This one goes up by 2. This one goes up by 2. So the rate of change is the change in y divided by the change in x, which in this case is 4 over 2. And of course, 4 divided by 2 works nicely. We don't have to leave that as a fraction because it's a nice number. 4 divided by 2 is just 2. So there we are. That's the rate of change. We're going to have to do the same thing over here. We're going to have to find the rate of change. And we can do that like this. We can say from 4 to 8, well, that's going up by 4. 8 to 12, that's going up by 4. 12 to 16, that's going up by 4. 16 to 20, that's going up by 4. 20 to 24, that's going up by 4. So these are all the same. That's nice. It's not always the case. Sometimes you do questions and they're not all the same. How much is this going up by? Well, maybe you can do that in your head. Maybe you can't. I'd probably want to use a calculator for that. I would say negative 60 minus negative 12 to see how much it changed by. And we'd see that this is actually going down. It's getting lower by 48. Wow, that's big. And it's going down by 48, and going down by 48, and down by 48, and down by 48. Those are big numbers, but not too hard to find. Too big to count on your fingers, but easy to find with a calculator. And so here we'd say the rate of change, well, it's just the change in y over the change in x. So it's negative 48, because this one's going down, divided by 4. And just like the other one, that can be divided nicely. A negative divided by a positive will be a negative, so it's going to be a negative answer. And 48 divided by 4, well, that's 12. So the answer here is that the rate of change is just equal to negative 12. Oh, I was supposed to use a green highlighter for that, in the interest of being consistent. So the rate of change is going down by 12. Now what about the initial value? And this can be tricky. In this case, the initial value, we have to know that it's the y when x equals 0. which doesn't appear on this table. So we have to ask ourselves, where would 0 go? Well, if x were 0, that's just one more step down here, right? That would have been just another 4 here. And every time this changes by 4, what does this change by? Well, it changes by 48. So it actually going up, it goes up by 48, because going down, it goes down by 48. So we would have to add 48 to this, just like we had to add 4 to this to get to 0. So this would be negative 12 plus 48. It's going up by 48 because we're counting up. And that would give me positive 36. So even though it's not shown on our table, that's the initial value, and we have to make it. We have to find the initial value because they didn't give it to us on the table. So that's the sneakiest example you could see. Not all the questions on this ask you to do that, which is great, but if it does, nothing to be afraid of. You just work your way backwards on the table, just like that.